Welcome the students of SC Civil for the subject surveying unit number 1 compass and leveling. So for this we will use the reference books Kanetkar Kulkarni surveying and leveling, Duggal surveying, Punmiya higher surveying, Subramanyam surveying and leveling, Basak surveying and leveling, and Das surveying. Now we will see the course outcome. On successful completion of this course, student will be able to first define and explain basics of plane surveying and differentiate the instruments used for it. Second, course outcome, express proficiency in handling surveying equipment and analyze the surveying data from these equipment. Third course outcome, describe different methods of surveying and find relative positions of points on the surface of the earth. Fourth course outcome, execute curve setting for civil engineering projects such as road, railways, etc. Fifth course outcome, articulate advancements in surveying such as space-based positioning systems. And sixth course outcome, differentiate map and aerial photographs, also interpret aerial photographs. Now we will see the course objectives. With the successful completion of the course, students should have the capability to describe the function of surveying in civil engineering construction. Next, identify the source of measurement errors and mistakes. Understand the difference between accuracy and precision as it relates to distance, differential leveling, and angular measurements. Third course objective, identify and calculate the errors in measurements and to develop corrected values for differential level circuits, horizontal distance and angles for open or closed loop traverse. Fourth course objective, effectively communicate with team members during field activities, identify appropriate safety procedures for personal protection, properly handle and use measurement instruments. Fifth course objective, be able to identify hazardous environments and take measures to ensure one's personal and team safety. Sixth course objective, perform traverse calculation, determine latitude, departures and coordinates of control points and balancing errors in a traverse. Use appropriate software for calculations and plotting. Seventh, operate a total station to measure distance, angles and to calculate difference in elevation. Reduce data for application in a geographic information system. Eighth course objective is work as a team member on a surveying party to achieve a common goal of accurate and timely project completion. Ninth course objective is calculate, design and establish curves, understand, interpret and prepare plan, profile and cross-section drawings, work with cross-sections and topographic maps to calculate areas, volumes and earthwork quantities. Now we will see the unit number 1, compass and leveling, this syllabus. It includes 4 parts, A, B, C, D. In A part it includes definition and importance of surveying, principles of surveying. In B part it includes definition, objective and fundamental classification of surveying, plane and geodetic, concept of scale, ranging, chaining, offsetting and traversing, construction and use of prismatic compass, concept of bearing and types of bearing such as whole circle bearing, quadrilateral bearing, meridian and their types, local attraction and correction for local attraction, deep declination and calculation of true bearings including numericals on all types. C part includes equipment required for plane table surveying, uses, advantages and disadvantages and errors in plane table surveying, methods of plane table survey, radiation, intersection, traversing and resection. D part includes introduction to leveling, types of benchmark, study and use of dumpy level, auto level, digital level and laser level in construction industry, principal axis of dumpy level, testing and permanent adjustment, reciprocal leveling, curvature and refraction corrections, distance to the visible horizon, collimation plane method, rise and fall method. Now we will see the part B, construction and use of prismatic compass, concept of bearing and types of bearings such as whole circle bearing, quadrilateral bearing, meridian and their types, local attraction and correction for local attraction, deep declination, and calculations of true bearings including numericals of all type. Now first we will see the construction of prismatic compass. The prismatic compass consists of a circular box about 85 mm to 110 mm in diameter, in the center of which is balanced a magnetic needle on a hard steel pointed pivot. The needle, which is of board form, carries an aluminum ring graduated to degrees and half degrees. The graduation starts from 0 marked at the south end of the needle and run clockwise so that 90° are marked at the west, 180° at the north and 270° at the east. The figures are written inverted. Diametrically opposite are fixed to the box the sighting vanes and the reflecting prism with a sighting slit at the top. The sighting or object vane consists of a hinged metal frame in the center of which is stretched a vertical crosshair, fine silk thread or fine wire. When the instrument is not in use or when it is being carried from point to point, the sighting vane is folded on the glass lid which covers the top of the box. When the needle points north, the reading under the prism should be 0. But since the prism is placed exactly opposite the sight vane, the south end will be under the prism. Consequently, the 0 graduation of the ring must be placed at the south end of the needle. By this means, bearings are obtained clockwise from north. So here we can see the figure number 1 of the prismatic compass. Here we can see the component parts. This is the magnetic needle. Then this is the pivot. Here the agate cap is there. Then this is the graduated disc. Then here it is a slit metal frame. Then here this horsehair is there. Then the mirror which is placed to see the object. Then this is the reflecting prism with cap. Then this is the eye vane. This is the focusing stud. Then these are the dark sunglasses. This is the box of the prismatic compass. This is the top glass cover. Then this is the lifting pin. Then this is the light spring. This is the brake pin or the knob. This is the lifting lever. And this is the support to fit on the tripod. Now we will see the temporary adjustments of the prismatic compass. First is the centering, then leveling and the focusing. Now we will see the surveyor's compass. The surveyor compass was formerly used in land surveying, but now it is not used. In general, it is similar to a prismatic compass except that it has another plane sight having a narrow vertical slit in place of the prism and that it carries an edge bar needle on the pivot. So we have seen the surveyor's compass. So we have covered the construction of the prismatic compass. Now we will see the use of prismatic compass. For horizontal angular measurements, prismatic compass is used. The compass does not measure the angle between the lines directly, but measures the angle between the magnetic meridian and the line. The theodolite, on the other hand, measures the angle between the two lines directly. So we have seen the use of prismatic compass. Now we will see the concept of bearing and types of bearing such as whole circle bearing, quadrilateral bearing, meridian and their types. The bearing of a line is the horizontal angle which the line makes with some reference direction or meridian. The reference direction employed in surveying may be true meridian, magnetic meridian, arbitrary or assumed meridian. The true meridian is usually employed in geodetic surveys, while the magnetic meridian is used in the plane surveys. Now we will see the true meridian. The point of intersection of the Earth's axis and the surface of the Earth are known as the North Geographical Pole and the South Geographical Pole. The true or geographical meridian passing through a point on the Earth's surface is the line in which the plane passing through the given point and the North Pole and the South Pole intersect the surface of the Earth. The direction of a true meridian at a station is invariable. The true meridians through the various stations are not parallel but converge to the poles. The horizontal angle between the true meridian and the line is called a true bearing of the line. It is also known as the azimuth. So we have seen the true meridian. Now we will see the magnetic meridian. The direction indicated by a freely suspended and properly balanced magnetic needle unaffected by local attraction forces is called as magnetic meridian or the magnetic north and south line. The angle which a line makes with the magnetic meridian, it is called a magnetic bearing of a line or simply a bearing of a line. So we have seen the magnetic meridian. Now we will see the arbitrary or assumed meridian. For small surveys, any convenient direction may be taken as a meridian. It is usually the direction from the survey station to some well-defined permanent object or the first line of a survey. The angle between this meridian and a line is known as an arbitrary or assumed bearing of the line. So we have seen the arbitrary or assumed meridian. Now we will see the designations of bearings. There are two systems of notations commonly used to express the bearings, like whole circle bearing system and the quadrantal bearing system. Now first we will see the whole circle bearing system, in which system the bearing of a line is always measured clockwise from the north point of the reference meridian towards the line right around the circle. The angle thus measured is called as the whole circle bearing, that is WCB. It may have any value between 0 degree to 360 degree. The bearings observed with a prismatic compass are the whole circle bearings. So here we can see the north, the south direction, east direction and the west direction. So this is the line AB, AC, AD and AF. So these lines, AB line making the angle with north, this is theta 1. AC line, the angle is made with the north is theta 2. Angle which is made by the AD line is theta 3. And angle made by the line AF from the north, that is the theta 4. Here the quadrants are given: first quadrant northeast, second quadrant southeast, third quadrant southwest and fourth quadrant northwest. So figure shows the whole circle bearing system. Now we will see the quadrantal bearing system. In this system, the bearing of a line is measured clockwise or counterclockwise from the north point or the south point, whichever is nearer the line, towards the east or west. It is therefore absolutely necessary to state the point from which the angle is measured and also the direction in which it is measured. In this system, the bearing is reckoned from 0 degree to 90 degree in each quadrant. The quadrant bearing never exceeds 90 degree. It must be remembered that the quadrantal bearing are never reckoned from the east or west line. The bearings observed with the surveyor's compass are the quadrantal bearing. They are often called as reduced bearing. It is denoted by RB, capital RB. Now here we can see figure 3 quadrantal bearing system. The north, the south the east direction and the west direction. So the the angle made by the line AB, it is alpha here with respect to north towards east. Then the line AC, it is made with the south towards east. Then AD line, it is made with the south towards west. We can say this as theta. And the angle made by the line AF with north towards west, that is phi. This is the quadrilateral bearing system. Now we will see the table where the reduced bearing can be calculated. The case first, whole circular bearing between 0 degree to 90 degree. Then rule for reduced bearing is the value which is there of whole circular bearing, it can be taken. Then the quadrant is northeast. The second case is when the whole circular bearing is between 90 degree to 180 degree. Then rule for the reduced bearing is 180 degree minus whole circular bearing, and it is in the southeast quadrant. The third case, when the whole circular bearing is between 180 degree to 270 degree, the rule for reduced bearing is whole circular bearing minus 180 degree. The quadrant is southwest. Then the fourth case is the whole circular bearing is between 270 degree to 360 degree. Then the reduced bearing can be calculated by 360 degree minus whole circular bearing, and it is in the northwest quadrant. Now we will see the fore bearing and back bearings. Every line has two bearings, one observed at each end of the line. The bearing of a line in the direction of the progress of the survey is called the fore or forward bearing, that is FB, while its bearing in the opposite direction is known as the back or the reverse bearing, that is BB. It will be noted here that the fore bearing and the back bearing of a line differ exactly by 180 degree. Now we will see the rule. The rule is back bearing is equal to fore bearing plus or minus 180 degree. Use positive sign if the given fore bearing is less than 180 degree, and use negative sign if it exceeds 180 degree. In the quadrilateral system, the fore bearing and back bearings are numerically equal but with opposite letters. The back bearing of a line may be obtained by simply substituting north for south or south for north and east for west or west for east. Now here we can see the figure for the fore bearing and back bearing. This is the north, station A is there. This is the line progress of the survey A to B. So this angle which is made with the north, that is the theta angle, the fore bearing, and the station B is there, the north direction. The angle made by the north with the AB line, that is the theta 1, that is called as the back bearing. Similarly, when the progress of the survey is from A to B, when the progress of the survey is from B to A, here we can see at station B the theta is there. From B to A, progress of the survey, this is called as the fore bearing, and at station A the opposite direction angle which is measured with north, that is called as the back bearing. So we have seen the concept of bearing and types of bearings such as whole circular bearing, quadrilateral bearing, meridian, and their types. Now we will see the local attraction. The magnetic needle does not point to the magnetic north when under the influence of the external attractive forces. The magnetic needle is seriously deflected from its normal position if placed in the vicinity of masses of magnetic rock or iron ore, and is also affected by the proximity of steel structures, rail, electric cables, conveying current, iron pipes, railings, iron lamp, post, etc. Care must be taken to see that the observer has no source of attraction such as bunch of keys, knife, iron button, steel rimmed spectacles, etc. Such a disturbing influence is known as the local attraction. If the forebearing and back bearings differ from 180 degree, there is no local attraction at either station provided the compass is free from instrumental error and no observational errors are made. There are two methods of correcting the observed bearings of the lines. First, in the first method, the true included angles at the affected stations are computed from the observed bearings, commencing from the unaffected line, and using these included angles, the correct bearings of the successive lines are computed. Second, in the second method, which is in most common use, the included angles are not computed, but the amount and the direction of error due to local attraction at each of the affected stations is found. Starting from a bearing unaffected by local attraction, the bearings of the successive lines are adjusted by applying the corrections to the observed bearings. So we have seen the local attraction. Now we will see the dip of the needle. If the needle is perfectly balanced before magnetization, it will not remain so after it is magnetized on account of the magnetic influence of the earth, but it will be inclined downward towards the pole. This inclination of the needle with the horizontal is known as the dip of the needle. In the northern hemisphere, the north end of the needle is deflected downward, and in the southern hemisphere, the south end of the needle is deflected downward. The amount of dip is not constant but varies in different parts of the earth. It is 0 degree at the equator and increases as the magnetic poles are approached until it is 90 degree, that is the needle is vertical at the magnetic poles. In order to counteract the dip of the needle, a sliding weight or rider in the form of a fine brass or silver wire coil is placed over the higher end of the needle at a suitable point so that the needle will be properly balanced so as to maintain a horizontal position. So we have seen the dip of the needle. Now we will see the magnetic declination. So here we can see the figure showing the magnetic declination. This is the positive declination. This is the true meridian. This is the magnetic meridian, and whatever this theta is there, this is positive declination is called. Then here we can see another figure where the negative declination is there. The true meridian is there and the magnetic meridian is towards the left hand side. So it is called as the negative declination. The magnetic meridian, that is the horizontal direction adopted by the geometrical axis of the needle unaffected by the local attraction at a plus, does not coincide with the true meridian at that place except in few places. The horizontal angle which the magnetic meridian makes with the true or geographical meridian is known as magnetic declination or the declination of the needle. When the north end of the needle points to the east of the true meridian, the declination is said to be east, that is north n degree east. When the north end of the needle points to the west of the true meridian, the declination is said to be west, north degree west, n degree west. Since the magnetic meridian varies from place to place on the earth's surface, the amount and direction of the declination is different in different localities. So here we can see the bearing with the magnetic declination. So the true north is there, true south, true west, true east, and this is the magnetic north. So here this OP is the line. So this is the magnetic declination towards east, and this is the magnetic bearing which is taken, and from true north it is the true bearing it is considered. Here Tn is the true north, Mn is the magnetic north. Here the Tb is the true bearing, Mb is the magnetic bearing, and delta, that is the magnetic declination, this is positive magnetic declination. So similarly here we can say true north is there, true south, magnetic north, magnetic south. Here the AB line is there. So here this is uh, the true bearing of a line AB is shown here, and from here, from magnetic north, this is the magnetic bearing, and here the delta will be there. This is towards west, so this is negative declination. So we have seen the magnetic declination. Now we will see the calculation of true bearings included numericals of all type. So rule number 1, that is true bearing of a line is equal to magnetic bearing of a line plus minus declination. Use positive sign when the declination is east and negative sign when it is west. Rule number 2, magnetic bearing of the line is equal to true bearing of a line plus minus declination. Use negative sign when the declination is east and use positive when it is west. These rules are applicable in the case of whole circle bearings only. So we have seen the part B, construction and use of prismatic compass, concept of bearing and types of bearings such as whole circle bearing, quadrilateral bearing, meridian and their types, local attraction and correction of local attraction, deep declination and calculation of true bearings including numericals of all type. So these are the YouTube links which are available on YouTube. Compass survey, study of prismatic compass, apply temporary adjustment of a prismatic compass, measuring angles with your compass, how to convert whole circle bearing to quadrilateral bearing or RB, reduced bearing English, how to bearings problems with math.com, earth parallels and meridians, latitude and longitudes, IGO-TV, compass survey, deep of needle, deep at south pole, deep at equator, UPSSC, JE, SSC, JE, RRB, JE, magnetic declination demystified. So we have seen part B, construction and use of prismatic compass, concept of bearing and types of bearings such as whole circle bearing, quadrilateral bearing, meridian and their types, local attraction and correction of local attraction, deep declination and calculation of true bearings including numericals of all type. So this is the syllabus of unit number 1, compass and leveling. Part A, definition and importance of surveying, principles of surveying. Part B includes definition, objective and fundamental classification of surveying, plane and geodetic, concept of scale, ranging, chaining, offsetting and traversing, construction and use of prismatic compass, concept of bearing and types of bearings such as whole circle bearing, quadrilateral bearing, meridian and their types, local attraction and correction for local attraction, deep declination and calculation of true bearings including numericals of all type. C part includes equipment required for plane table surveying, uses, advantages and disadvantages and errors in plane table surveying, methods of plane table survey, radiation, intersection, traversing and resection. It also includes part D, introduction to leveling, types of benchmark, study and use of dumpy level, auto level, digital level and laser level in construction industry, principal axis of dumpy level, testing and permanent adjustment, reciprocal leveling, curvature and refraction correction, distance to the visible horizon, collimation plane method and rise and fall method. Thank you all students.